Hi, Chuck Kinkley here. I want to talk a little bit about climate change. I see a lot of stuff online, um, and uh, it's time to have this conversation. I've long said that we don't really need to talk about climate change if we're going to support renewable energy development, which is what I do, um, because projects kind of stand on their own on an economic basis. However, time has kind of passed that by. So I have here my screen shared, and what we've got here is 174 years of climate data. And you can see that the data was blue for a very long time, and then it started to turn red. And you can tell if you go look at this, these are called stripes. It's very, very red right now. So what is the probability that this time series is just natural variation and weather, if you will? Not very likely. So to get to the punchline, there's about a 1 in 2.5 with 16 zeros behind it probability that the last 10 years, so those red years, would have happened in a row if this was natural variation. I think really that's the pitch. Like in the olden days, when I talked to people about climate change, I'd have to talk about 1998 and the pause, and why years were hot and cold, but we were still going up, and human fingerprints and all that stuff. But we don't need to talk about any of that science anymore. We don't need to talk about models anymore. It isn't about models. The climate's already changed, and it's changed because of us. So let's just go convince ourselves that the climate's changed. Can we do that? Let's look at this picture. I'm pretty convinced looking at this picture, but yeah, it's a picture. So let's look at the information that goes into that picture. And that there's several data sources. We'll get into that before we're all over with. But I used the UK government's Met Office data. The reason I used it is because it's in a very easy format to use. And you can go right online, right here, and get it and use it. I mean, you can do that with the US government's data set. You can do it with other data sets as well. I use this particular data set. It doesn't matter which data set you use, I assure you. So just go here, go click download the data yourself. I did that. I put it in the spreadsheet, years, anomalies. Then I just put it in Excel. That's all I did. And looked at the mean and the standard deviation, and some other kind of descriptive statistics, and I put them on a list. And I asked myself, for each of these years, what is the percentile? What is the probability on a relative basis that these temperatures would have occurred? And I did no more. There's no fancier than going to Excel and going to the data section and clicking the data analysis tools and using them. That's all there is to it. Nothing fancy, no algorithms, no fancy computer programs. This is something that any high school kid could do. So you then figure out all these percentiles, and you can see, a lot of years were in the 40s and 50 percentile, just like you'd expect. This year we're in the 50th percentile, so that means that year was a very likely year given this particular time series. And what year was that? That was 1938. So the last time we had a P50 year, 50% probability year, a year where half the numbers were above it and half the numbers were below it, was 1938. That's the cold years in the 40s. come down here. Just kind of like a big snow year of my youth, 1978. Sure enough, was a relatively cold year. What happens here is we kind of get past 2007. We hit this 90% probability point. So this year, it was 90% probable that all the numbers would be lower than the number we observed that year. The next year, 91%. It only took 10 years to go from P90 to P95. So we hit P95 in 2015. And what's happened between 2015 and 2023? We went to P99. What does that mean? It means there's a 99% probability that any of these years' temperatures was more than the temperature we observed in that particular year. So I'm asking myself, what is the joint probability? The probability that you had the P95, P95, P96, 96, 97, 97, 98, 98, 99 year. What is that probability? Well, it's not hard, just formula. Where is, oh, here it is. It's just each of those. So there was a 5%, 5.46% probability that top one occurred, 4.89, down to 0.29% probable where we are today. So in other words, given this time series, if it was just a natural variation, in 2023, we would be at 0.29% likely. That's not very likely. Now, what is the likelihood of all those years happening in a row? Well, I'll tell you what it is, because I just multiplied them together. It's called joint probability. What did I get? I got 0. I changed my format here, right here, live in front of you. I'm kind of not happy about that. Sorry, I'm going to go fix it. Because I know what the number is. There we go. So the number's so low, the Excel returns a 0. And I would have to go click 16 zeros before any number would show up. So in scientific notation, there's a 1 and 2.5 with 16 zeros behind it probability that this last 10 years would have occurred if this was natural variation. So guess what? It's not natural variation. Well, at least it's not very likely. So I always was wondering about climate change, like what would happen when the climate skeptics just could no longer deny, it just got so hot that the Earth already changed. And that's where we are. That's happened. We don't need to talk about Al Gore or models or I didn't like this UN report or the sun or the wobbling Earth. We need to talk about anything. We just need to realize the climate's already changed. I encourage people to do this. There's something kind of comforting about getting data, analyzing data yourself. It makes you kind of look at the data and understand the data. And I assure you, if anybody did that, they would understand the climate's already changed. I'm just going to cancel that. I'm going to make that little, get out of your way. Now, back to the data. I love this guy, Dr. Mueller. He was at Berkeley, University of California at Berkeley. He's a physicist, very well known and an excellent physicist. Had a very long and successful career. He was a climate skeptic. He said, I don't believe your data. I don't believe how you're getting it. I don't believe how you're processing. It all looks a little hokey to me. So he and actually some other climate skeptics got together and they got money from the Koch, family conservative donor guys, and they made their own data. Well, what did they find? They found that the climate's changing, and they found that the climate's changing due to CO2, and they found that the climate's changing due to CO2 that was made by man. So I highly recommend that all the data is here. The data visualization, you can go look at the data. They've got YouTubes about it. I mean, I could talk about some of this stuff, but it's a little wonky and it's a lot easier to say 2.5 was 16 zeros, but this really what we're talking about is 2.5 was 16 zeros, just in more kind of wonky talk. You can download this data. You can do the same thing with this data as I did with the UK Met Tower, the UK Met Office data, and the result is going to be the exact same. Now, what's old Dr. Mueller say here? Dr. Mueller, I was wrong about climate change. Go watch this video. Just go to YouTube. Dr. Richard Mueller, I was wrong on climate change. Just watch it yourself. Very good video. Very worthwhile project. So here, climate skeptic looked into it. Sure enough, came around. Climate.gov, very good site. That's run by NOAA. And the thing that is concerning to me is the last couple of years. You saw how hot they were because it was right in the data. The Earth was very warm the last couple of years. The last couple of years, we've had relatively cool cycle because we've had La Nina. I was wondering myself the last couple of years, it's very hot. There's the La Nina. What's going to happen when El Nino comes and the Earth and the ocean heats up and the Earth gets warmer? Well, this is what happens. 2023 happens. So we're in the very early stages of the ocean heating up, and that's going to cause the ocean. By the ocean, I mean the Pacific Ocean here, right here. And that's going to cause the global temperatures to go up. That's why we have the hottest days on Earth right now. So June or July 4th, hottest day on Earth. You're going to hear that hottest day on Earth 100 times in the next 2 years because we're just the climate's changed. There's just no getting away from that. Now, the one thing about the ocean that's worth noting too is the ocean has absorbed an awful lot of heat, and so it's really kind of saved ourselves so far. Otherwise, we'd be a lot hotter right now. The other interesting thing is there's more ocean in the southern hemisphere. So, in other words, the southern hemisphere has heated up less rapidly than the northern hemisphere. It's kind of interesting. I was watching Fox News the other day, and they were saying, "Oh, it was the hottest day on Earth. The average temperature was whatever, 68 degrees or whatever it was, 63 degrees or whatever. I forgot." And I'm like, guys, that's the average temperature for the world. Like, don't you know? We're in summer here in America, but they're actually in winter in the southern hemisphere. So the average being the hottest day ever, doesn't matter whether it's 63 degrees. It's the hottest day ever, and it's too hot, and the temperature has been rising too quickly. Huckabee was on that. I like Huckabee, and he's like, "Oh, we should, God's gonna, I don't know what he brought God into it somehow, I don't remember. But God gave us the intelligence to figure this shit out. I think that's what God told us. So I'm going to go make these men. I'm going to let them be smart, and they're going to figure this out, or they're just going to be self-destructive and, go extinct. It's my own view. There's a really good, I like this NOAA site. This is NOAA on climate. And what do I want to talk about? Oh, the thing about hurricanes, the thing about hurricanes is the water's heated up, so it's more the more energy can be absorbed into a hurricane. But La Nina or El Nino actually increases the wind shear, which decreases the ability of hurricanes to form. So we'll see what wins out: the wind shear blowing the hurricanes apart, so they don't form, or the fact that the water's so hot that there's so much energy that hurricanes likely. The reason why I like talking about this NOAA site is they just go in there and say, hey, we actually collect data from the ocean. And this is true with satellites, too, by the way. So every year, this is how much data they collect. They collected a little bit of data, they collected a lot more data, and now they collect a ton of data. So every year, we're getting a year's worth of additional data. Every year, we're getting more and more data than we did the previous year. So our uncertainty around this data we're collecting every year is less and less and less and less. And oh, by the way, we're using instruments that are more and more capable. Okay, the last thing, and then I'll go on to go to dinner, is scientists have known this for a long time, and I've had conversations with people, and in the old, I'd have to go walk them through science and books, and even the books that were written, the physics of climate change for dummies, and the books that the physicists thought they were writing for the average people. They didn't really write them for the average people. I'm sorry. So yes, if you had a scientific background, you could pick the book up. It was a very easy read. Tangential point. 10 years ago, this wasn't this clear. 20 years ago, it wasn't clear at all. So the fact is, these natural phenomena like weather, for example, and global temperature and rain and how much flow goes down a river does tend to have fat tails, if you will. And it does tend to have a chaotic a pattern to it, and that is not just a nice, beautiful Gaussian bell curve. It does tend to be more. Does tend to be more to it than that. So I do think, and that's well known. So there's the fractal geometry of nature. There's critical phenomena, critical behavior of natural phenomena. There's all sorts of books about this, right? However, we're past that. Like it doesn't even matter like what distribution you're comparing this actual data to. We're still something with 16 or 17 digits away from this being likely. Now, the scientists have been onto this for a long time. And so a couple of years ago, they said, geez, if we educated the public that all the scientists actually agree to this, maybe the public would be more receptive to believing this. And so these people, this guy, John Cook is kind of the leader of this, but there's a well-known professor of the history of science, this Orestes, that's all into this too. Back in 2004, she did a study, wrote a paper, 100% of the scientists, and then Cook back in 13, 97% of the. I've seen different of these studies, 98, 99%, 97%, 100%. The fact is, there's like a very few scientists that don't believe in climate change. And also the fact is, the more that the scientists spend in this sector, the less there are. There's really one, assuming that one or two people are dead that I haven't heard of for a few years. There's really only one bona fide climate expert. And anymore, she's not saying there's no climate change. She's saying, don't worry about it. Well, I'm kind of worried. This is pretty alarming. The other 97% of her colleagues are pretty concerned. So that's kind of the news. The news is, I don't want to talk about a model. I don't want to talk about Al Gore. I don't want to talk about the dinosaurs. I don't want to talk about 400,000 year time series. When I see a chart that has 400,000 years on it, which is a very common chart, and it doesn't show that we're off into the Netherlands, I look at the end date, and the end date tends to be 1960. So yes, if you have a chart that starts at 1960 and it goes 400,000 years back, you don't see the climate change that's already occurred, because it didn't occur in 1960. It just occurred in the last 20 years. I don't know what we're going to do about this. I wish the politicians would stop taking the position that there's no climate change, because why take a position that you're already wrong on? It's not helpful. I hope people found this helpful. I had to get it off my chest. I don't really care if anybody watched this video or not. I'm just done listening to all of these crazy arguments that there's no climate change. It's just, anytime someone says, well, what about, and goes off on some obscure tangent, what about the fact that it rained a lot in 300 BC? It doesn't matter, guys. Just look at the numbers. Go get some high school kid and have him run these statistics for you. Thank you very much.